Hey everybody. All right, so we're moving on now in grade 10 academic math to lesson 4. We're going to look at some properties of rectangles and triangles. So we're going to take what we learned about medians and distances and all that sort of stuff and everything we know about geometric shapes and try to put them together. So try to basically quantitatively analyze rectangles and triangles. So I'm going to give you an example involving a quadrilateral. So let's say we have a quadrilateral, and all you're given is the 4 vertices, the coordinates, the x and y coordinates of 4 of the vertices. A is -4, 1, B is 1, 4, C is 4, 2, and D is -1, -1. What is it? Is it a square, a rectangle, a rhombus, a parallelogram, a trapezoid, or a kite? Those are 6 different types of quadrilaterals. Quadrilateral means 4 sides. Quad, lateral, 4 sides. And we can put those sides together in ways that, have parallel sides or don't have parallel sides, have side lengths that are the same, or that don't have side lengths that are the same, or angles that are 90 or not 90. So we had to figure all this stuff out to figure out what kind it is. Then once we've done that, it asks us to find the midpoints of the diagonals. Right? Diagonals mean the side that connects a vertex to its opposite vertex. So like in this square, for example, this this side length, we're trying to figure out that diagonal there. Okay, so to do this, we need to determine all the side lengths and all the slopes. So let's look at the slopes first. So we can use our slope calculations. These are formulas that we learned in grade 9 about how to calculate the slopes. We're going to do the same. We're going to calculate the slopes for all the side line segments. Sorry, AB, BC, CD, and DA. Okay, so let's say for AB, I can plug in my values, the y values and the x values, and I come up with a value of 3/5. Let's just leave it as a fraction instead of, well, that'll be 0.6. And we can do the same thing for all the other sides. I'll spare you all the nitty gritty there, and I just did it all for you here. And what do we notice? We notice that slope of AB and CD are the same. Also BC and DA. So what that tells us is that AB and CD are parallel, as well as BC and DA are parallel. Okay, so we know we have 2 pairs of parallel sides. However, we don't have right angles. Because these are not inverse reciprocals of each other, remember, if we know a slope, we can always get a perpendicular slope by finding the negative reciprocal. Remember what that means is you take the value, you make it negative, and then you flip the fraction. That's why I left it as 3/5, right? If we would flip that, it would become, its negative reciprocal would be -5/3. Instead, we have a slope of -2/3. So therefore, these are not, I apologize, 1 second. Sorry, yeah, they're not perpendicular to each other. Okay, so what can we figure out from this? What can we figure out just from that information? So, could it be a parallelogram? Does that have parallel sides? Yes, so it could be that one. A rectangle, they have parallels, 2 sets of parallel sides. Rhombus, square, trapezoid. Oh, can't be a trapezoid. What about a kite? Not parallel sides, right? So trapezoid, these 2 are parallel, but those 2 sides are not, and no sides are parallel in a kite. Okay, so we have 4 possibilities. Actually, no, we can't, because we know that it's not right angles, right? So we can't say it's a rectangle or a square, because we know that there were no right angles. So the side is either a parallelogram or a rhombus. Now, rhombus has all 4 sides the same. A parallelogram has 2 different side lengths. So let's do the calculation now for side lengths. So we're going to use our distance formula to find out the distance of AB and BC. And we end up with, doing all the calculations here, we end up with an answer of root 34. Now, I had a few of you ask a question if you should leave it like that, leave it as a radical. And we say that this answer, root 34, this is the exact number. This is the exact value. Once we go and plug it into our calculator and it gives us a value of 5.83, this has a whole bunch of decimals. It basically has infinite decimals. It's an irrational number, we say. A rational number means that we can't represent it as a fraction, which also means that it'll have an infinite number of decimals. So which means when I say that the answer is 5.83, I'm cutting off, I'm truncating that number. I'm removing all of that information, and it becomes approximate. So as you can see, I put a little dot on top of the equal sign to show that that's the approximate length, right? It makes more sense to us when we say 5.83. I can picture a length of about 6, right? Because 34 is close to 36. Square root of 36 is 6. But root 34, that takes me a little bit to think about. Okay, close to 36, about a little bit less than 5. A little bit less than 6. Right, so we like the number 5.83, but it's not exact. I'd like you when you do this work, leave the answer as an exact value. Like for example, the distance BC, once you plug in all the numbers, we get root 13. Now, if we do the same thing for CD and DA, we get the side lengths we have 2 pairs of side lengths, root 34 and root 13. So that tells us, since there was 2 pairs of parallel lines, there was no 90-degree angles, and we have 2 different side lengths, our quadrilateral ABCD is a parallelogram. All right, so we did a bunch of quantitative analysis to actually find this out. We could have done this as well. Well, we can't really. This is how we solve the problem. Let's cheat, kind of, and look at this from a visual point of view. So this is using this Geogebra. I really don't like that word. This Geogebra software. You go to this word.org, and you can plug in your numbers, go A equals, and you get these, and we can come up with line segments, and it will give us this this parallelogram. And as you can see, these are parallel, and these side lengths are not the same. Even if you go here and you made those line segments, it even tells us these side lengths, 5.83 and 3.6. So this side F, which is over here, that's 5.83, and G is 3.6. All right, so we can see that's a parallelogram. And now it asks us to calculate the midpoints. So of the diagonals, sorry. So we're going to create diagonals. I can go from B to D and A to C. And the question was, is this what are the values here? And as you can see, they're interesting. Let's actually do the calculations for part B. So determine the midpoints of the diagonals. What do we notice? So this is our midpoint formula. We take the average of the x values, the average of the y values, and if we do that for AC, we get 0, 3/2. So it's an x value of 0 and a y value of 3/2. And if we do the same for DB, oopsies, 1 second. Sorry, I had the subscript there wrong. So if you can see, we end up with the same midpoint. So the midpoints of the diagonals are the same. So what that tells me is the diagonals bisect each other. The diagonals bisect each other. The diagonals of the parallelograms, diagonals of a parallelogram intersect at a midpoint. That's an interesting idea. Let's go back to Geogebra and see what happens. If I construct a midpoint of this line, it's point E, and if I construct a midpoint of this line, it's also there. So we end up with a midpoint. Let's see if it gives us the value here. There's gives us our midpoint values: 0, 1.5 or 3/2, and 0, 1.5, 3/2. So the diagonals actually cut each other in half. And is that the case for any parallelogram? It's an interesting result that we came up with, but is it only true for this specific parallelogram, or is it true for all? So what I'd like you to do, this is not part of the actual course, but this is just a quick bonus for any of you who have some time and want to think about this. is there a way that we can show that any generalized parallelogram, any parallelogram that exists, for all parallelograms that exist, the diagonals bisect each other? Now, when we have if you ever go into higher level mathematics, like university level mathematics, your textbook will always look like this. It'll give you a theorem, and then it'll give you basically a big idea. And then it'll show that idea actually is true by doing what we call a proof. And I want to see if you guys can show me in some way that all parallelograms actually have diagonals that bisect each other. How would we do that? How would we set up a general parallelogram where all the slopes are the same? Where do their diagonals work? This is a very difficult question. Okay. The assignment is actually pretty straightforward. You guys can, I think you shouldn't have a problem with that. Once you've figured out how to calculate slopes and distances and midpoints and that sort of stuff, the doing this actual stuff is okay. But this is a little extension problem for any of you, any people who want to really think about what this mathematical ideas mean. All right. So good luck working on the assignment, and I'll be talking to you later.